is I believe this is where we stopped off Friday. Was half angles, but we're not actually going to be using the half angle formulas. We're just going to solve it normally. Because, I mean, technically we probably could use the half angle formulas to find the values for these here, but we don't have to. So I'm not going to worry about those. Because what we can do is solve this normally. So we want to get 3 tangent of x over 2 plus 3. We want to get tangent by itself. So the first thing we can do is subtract 3 from both sides. Which tells us 3 tangent of x over 2 is equal to -3. At this point here, we can divide both sides by 3, telling us that tangent of x over 2 is equal to -1. Now at this point here, again, we're looking to see where tangent of x over 2 is -1. And incidentally, there's 2 places, because again, tangent is equal to 1 or -1 when the value of sine and cosine are the same. So we're looking at square root 2 over 2 and square root 2 over 2, which is our pi's over 4. Now, we need it to be negative, so we're looking for where one value of sine or cosine is negative and the other is positive, which is 3 pi over 4 and 7 pi over 4. Now again, because it didn't tell us that we had to be between 0 and 2 pi, we have to add 2 pi into it. So we have these 2 statements here. Questions on this so far? Well, to finish up and get x by itself, well, we have to multiply both sides by 2. Here, when we multiply the 2 and 2 will cancel, giving us x. Here we have to distribute the 2 between both of them. And 2 times 3 pi over 4 gives us 3 pi over 2, because the 2 and 1/4 will simplify. Plus 2 pi n times 2 gives us 4 pi n. And that's one of our answers. We'll do the same thing to the other equation. Multiply by 2. Tells us x is equal to 7 pi over 2 plus 4 pi n. And that's it. Questions on this here? So we'll look at one more of these here. And incidentally, we're still using tangent. But we do want to get it by itself. So we add 2 to both sides. Then we divide both sides by 2, telling us that tangent of x over 2 is equal to 1. So these are almost going to be the same angles because we're still looking at pi's over 4, but this time we want it positive. So one of them actually is pi over 4. As for tangent to be positive, sine and cosine have to both be positive or both being negative. It's one or the other. And so the other one is pi over 4. And again, just like with the last one, we do have to add 2 pi n to both sides. And to finish this up, we're going to multiply both sides by 2, telling us x is equal to, distribute the 2, would be pi over 2 plus 4 pi n. On the other one, we would distribute the 2 also, telling us x is equal to 5 pi over 2 plus 2 pi n. Oh, not 2 pi n. 4 pi n. And I mean, realistically, these are the same statement, because if we do add 4 pi to pi over 2, 4 pi plus pi over 2, we get 9 pi over 2. Okay, so they're a little bit different, because that's what I was thinking, because there's not a good way to get from one to the other or make them be the same. And if it, well, it possibly is, it is possible, but it would do some working and or kind of working the two equations out to get them to be the same. Wondering if it is. Yeah, because there's a good chance we could get it to be 2 pi n, x equals pi over 2 plus 2 pi n as one statement, because then they would be jumping back and forth between each other. But we can leave it as this here. We don't have to rewrite it. Questions on this here? All right. Secant squared of x minus 2 tangent of x is equal to 4. So we've done these already. Awesome. But I think it's good to look at these again. Now, because we do have a squared term, a term to the first power, most likely we're looking at quadratics. Tangent squared plus 1 is equal to secant squared. That's useful for us because we can replace secant squared in the equation with tangent squared of x plus 1 minus 2 tangent of x is equal to 4. I'm just going to rewrite it in standard form so we have our squared term, first power constant, and we get this here. Now, if we're going to solve this quadratic, we need it equal to 0. So the first thing we can do is subtract the 4 from both sides, telling us that tangent squared of x minus 2 tangent of x minus 3 is equal to 0. Now at this point we can factor it. We could use u substitution, actually. Let's just use u substitution. Because we can say u is equal to tangent of x if you feel comfortable using just tangent and factoring it with tangent, you can do that. You don't necessarily need the u substitution. And I'll show that here in a minute. Because if we factored this here, there is no greatest common factor. Since the third term is negative, our signs are opposite. Factors of u squared are u and u. And the only factors of 3 are 1 and 3. Now, since the middle term is negative, we'll probably want the bigger term to be negative. And that works out quite nicely because the numbers in front of you are both 1 and 1, so it has a bigger impact on it. And if we did check this here, u times -3 would be -3u. 1 times u would be plus u, which does indeed give us the -2u we wanted. So that's it. And really, if we wanted to have factored this without using u substitution, we would have done the exact same thing, but instead of saying u, we would have said tangent and tangent. Because the factors of tangent squared would be tangent and tangent. Now at this point, since we do have it as u substitution, we can go on and solve for u in both cases. Here we can subtract 1 from both sides, telling us u is -1. Here we can add 3 to both sides, telling us u is equal to 3. Now, we said u was tangent of x. So tangent of x equals -1. We're going to have to go back for a second, but we'll do that here in a minute. I knew something was off in my head. And the same thing is true here. Tangent of x equals 3. Now, it didn't give us a restriction from 0 to 2 pi, but we need to find these here. And luckily, for the first one, tangent of x equals -1 is on the unit circle. It's dealing with our pi's over 4. Now, they've been using the calculator throughout the whole thing. Looks like. No, because they've kind of been jumping between the two. Because if we plug, because what I'm saying is if we plug this in a calculator as tangent inverse of -1, arctangent, we get this, or -pi/4. So since it's not between 0 and 2 pi, technically leaving it as -pi/4 is the correct answer. Now, now this part here is what I'm going to have to go back and fix, because I didn't realize. Not that I didn't realize, I got stuck in the fact that we're plussing 2 pi in, 2 pi in. And it's not true for all of them. Is for tangent, the period's pi. That's why we were adding 2 pi for sine and cosine, because their period was 2 pi, because they repeat themselves every 2 pi units. Which here, we're dealing with tangent, so they're not actually repeating themselves every 2 pi units, they're repeating themselves every pi units. Which when we multiply by 2 would indeed give us 2 pi. Which now makes things make a little more sense, because these two actually are indeed the same statement. Two pi n. Yeah, because even the one we did to start with could have just been pi n or 2 pi n to finish. Mm-hmm. 3 pi over 2 plus 2 pi n is the general solution for this here. And it's really, they did on the interval of 0 to pi, x over 2 is 3 pi over 4 is the only real solution. And I mean, these are, end up being the same thing. Is what we get. Does that kind of make more sense? Yeah, I don't know why I was just, it wasn't until I was looking at this one here that I realized something was a little off. And even with the negative pi over 4 plus pi n, negative pi over 4, plus if we just add pi to it, we get our 3 pi over 4, which is indeed one of our negative ones because it's in the second quadrant. If I add pi to it again, we get back to 7 pi over 4, which is our negative pi over 4, and it kind of jumps between the two. Now, this one, tangent of x equals 3. We're going to have to actually use our tangent inverse for this one because 3 is not on the unit circle. Because tangent of 3, arctangent, 3 is a decimal, okay? It's still a decimal. We do have an angle for it. It does work. It's not one of our nice angles or nice radian values. So, and the book actually does leave it as arctangent of 3 plus pi n. It just left it as that. Because if we were actually restricting it between 0 and 2 pi, then we could actually have 4 values and do a decimal approximation. But we're leaving it as this here. I think my best guess, and interpreting from the book, is one, it just said to solve. It just said to solve this, we did. And we found it in the general form. And it looks like, again, with most of these, it's a non-repeating, non-terminating decimal because we're dealing with pi. So we would have to approximate. And I think most mathematicians don't like having to round or approximate if we don't have to. Arctangent of 3 is the exact value. Let's leave it as that, not the decimal approximation. Questions on this? For tangent squared of x plus 5 tangent of x minus 6 on the interval of 0 to 2 pi. We want to find all the solutions for this here. Okay, yeah, I just wanted to do one of these with on the interval of 0 to 2 pi. Now, we've done this by u substitution. Let's give it a try with tangent. So if we were to factor this, since the third term is, well, there is no greatest common factor because of the 5. Throws everything off. Since the third term is negative, the signs are opposite. One's going to be positive, one's going to be negative. If the third term had been positive, the signs would be the same and match the sign of the middle term. Now we do need to find the factors of the first and third term. Now, tangent squared, we're going to have tangent and tangent. It's actually not possible to have tangent, because I mean, technically, factors of tangent are tangent, and 1 and tangent squared, because those are the factors. But we can't have tangent squared and 1. because then one of them would have 1 in a number, it would simplify, and we wouldn't get back to a trinomial. It's not normally talked about because it's just kind of, this is understood, we're just going to push it to the side. But the other part of this is finding the factors of 4, which is 1 and 4 and 2 and 2, and the factors of 6, which is 1 and 6 and 2 and 3. Now out of these two here, let me get this mustard yellow. 2 and 2 is not going to work for 4, because we've kind of gone over this. The greatest common factor, if there wasn't 1 to begin with, or if we factored it all out, there can't be a 1 in either set of parentheses. Because if I use 2 and 2, no matter how I set it up with 1 and 6, or 2 and 3, there will be a greatest common factor of 2, no matter how we set it up. So that's nice, because that means that's gone. So 2 possible, well, 1, 2, 3, 4 possible arrangements for this here, technically, but really 2, is gone. So we're looking at 1 and 4. Now, most likely, the middle term is, well, not most likely, the middle term is positive, so we want the bigger number to be positive. So my best guess would be putting the 4 with the minus, because that means that 4 is going to multiply with the positive number, giving us a bigger positive. Now, I feel like 1 and 6 is going to be a little too big, because we'll have to do the 4 times 6. It's going to give us a big number. So I try the 2 and 3 first. And if we distribute this to check, tangent times -3 is -3 tangent of x. 2 times 8, 4 tangent of x would be 8 tangent of x, which does give us a positive 5 tangent. So these are the correct factors. And I think that's a little deeper into factoring than I normally go, but at this point, y'all are used to factoring and can kind of see those connections. Now we do have two things multiplied together to equal 0. So one of them must be 0. I feel like I left the x out of tangent of x, but it's not that big a deal. Okay, that's all connected. Okay, so we can solve the one on the left first by subtracting 2 from both sides, telling us tangent of x is equal to -2. We'll finish up solving for x here in a minute, but we did get tangent by itself. Now the one on the right, we would add 3 first, telling us 4 tangent of x is equal to 3. Divide both sides by 4, telling us tangent of x is equal to 3/4. Well, -2 and 3/4 are not on the unit circle again. So what we would have to do is arctangent. So we can do arctangent of -2 is one of them. And still not a nice number. But we can add pi to it, which would give us this here. Now, I realize I'm going to have to go back and fix this, because we were doing, and what I'm really doing is plus pi in to get these values. And for the sake of this problem, we're going to approximate, because arctangent of -2 gave us negative 1.1071487 radians. So that's not between 0 and 2 pi. We had to add pi to it, which gave us 2.3044. Yeah, 344 as one of our radian values. I'm going to write this over here as a side note. Zero 2 pi. Just kind of as a reference point, as a decimal would be 6.28, going on. So we have this here. Now I could add pi to it again, because it repeats every pi units. 5.176 is also between 0 and 2 pi. So if we had to get it in these forms, we would have it as this here. I mean, truly, the first one is x equals arc tan of -2 plus pi, and x equals arc tan of -2 plus 2 pi are the exact forms of these two answers, but those are also the decimal approximations above it. Now we can do the same thing with this here, arc tan of 3/4. Let's see what we get. Arctangent of 3/4 is 0.643500. That's fine, 0.6435. I'll write it out to the side. This is just arc tan of 3/4. Definitely not going to be a 0. But we can add pi to it because it does repeat itself every pi units. 3.7851. Is the rounded version. Which is just our arctan of 3/4 pi. And I have a good feeling that if I added pi again, we're outside. Does that make sense? And most likely on problems like this here, it's not going to say on the interval of 2 pi, 0 to 2 pi, and if it did, we'd probably get better values than these. I would make sure to check that on the test. And if I did have something like this here, I will warn y'all ahead of time. So you're not getting funky numbers like this without knowing it should come that way. Questions on this here? We have technically 2 more. I'm going to do 1 more because for the most part, this isn't too bad because we're doing this by the quadratic formula. Negative b plus or minus b squared minus 4ac all over 2a. Because again, for the most part, this equation here, sine squared of x minus 3 sine of x minus 2 equals 0 is a quadratic. And all we've got to do is modify this equation one little bit. And we can use it. Or essentially, we're using u substitution and substituting sine of x with, well, x to work with this equation. But it still works. And it is helpful because, well, as we'll see, this doesn't factor. So we have our negative b, negative 3, plus or minus the square root of negative 3 squared minus 4 times a times c all over 2a. because A, the number in front of sine squared is 1, B, the number in front of sine is -3, and C, our constant term is -2. And we would have sine of x, not x. Questions on this here? Now, for the most part, when we went over this the first time and we walked our way through it, we did a lot of this by hand. I would do a lot of this by the calculator. Now, normally -3, I would have just plugged it in as +3 when I started the problem and plugging the numbers in. Because a negative, we can do that in our head. That's fine. The 2 times 1 in the denominator, I would have written as 2. Because multiplication of 2, fixing our signs, I feel like we can do that pretty easily. I still write out the -3 squared minus 4 times 1 times -2, especially when solving it. In the calculator, that's the first thing I do. -3 squared minus 4 times 1 times -2 is 17. Well, actually, now the question is, can we reduce the square root of 17? Well, no, 17 is prime. Even if it wasn't prime, 17 does not have any prime factors, perfect square factors. So 4, 9, any of these here. So that's really as simplified as it gets. Now we'll have to use our sine inverse to get there to approximate the solutions. So what we're saying is that x is equal to arc sine of, we'll have the positive case, 3 plus the square root of 17 over 2. Now, because it is sine, we do have the 2 pi in. Now, this seems odd because we do have multiples of 2 pi. I mean, well, we're putting the 2 pi in, but we said it's restricted between 0 and 2 pi. Now, obviously, 3 minus the square root of 17 over 2 and 3 plus square root of 17 over 2 is not on the unit circle. But, and that's fine. It's just we have to add the 2 pi in because it will only give us one angle for either one of these, and it's going to restrict it between negative pi over 2 and pi over 2. So we have to use the 2 pi in technically to find the other one to get there. But, and it actually, yeah, we'll do arc sine of, first arc sine of R3 plus secant square root 17 all over 2. Domain error. Now the question is probably why domain error. I'm just put a parenthesis so it doesn't. We get that, which is 3.561. We can't put that into arc sine because sine itself cannot have a value greater than 1, so it doesn't work. Let me come back, put this in. So this first one doesn't exist. This is an extraneous solution. That one doesn't work. Now just taking arc sine of this here gave us negative 0.5962 5963. So we'll approximate it to 4 decimal places for this here. Now it did want this to be between 0 and 2 pi. Note that the solution is not between 0 and 2 pi defined, the solution. This here we can sketch. Well, it ends up saying that we just add 2 pi to try to get it back in between 0 and 2 pi. 5.689 or 5.68692. Almost. And we get this here. And that's the only solution because unlike, well, with most values with sine and cosine, there's only one actually, that really repeats itself multiple times, and that is 0. 0 is the only one that shows up more than once. So that's the only one that works. Does that kind of make sense? It's weird how that works, and I think you guys already have that down. Yeah. But